Example number 4. Suppose that a Piper aircraft flying west a distance of 500 miles takes 5 hours. The return trip takes 4 hours. Find the airspeed of the plane and the effect that wind resistance has on the plane. We're talking about the motion problem, so we recall that the formula for the motion is the distance equal rate times the time. So we will draw the table. So we will have the first one is rate, the second one will be time, and the last one will be distance. And we know the formula is rate times the times equal to the distance. In this case, rate is mile per hour, time is hours, and distance is mile. We have the problem say that the flight go west, so is one direction. And we have, they said that return that means go east. So when the flight go west, a distance of 500 miles, so that is for distance, and 5 hours is for the time. And the return trip take 4 hours. So when we go to a place and then when we return, the distance will be the same. So if we take 5 hours to get there and then we return, if it's 500 miles to get there, when we return it will be 500 miles also. And the return takes 4 hours. So what do we have in here is that with the same distance, but why the time is different when the flight go west and when the flight go east is shorter time. So 4 hours, so shorter time. So we can understand that there's a wind effect on the speed of the airplane. If the wind and the airplane travel the same direction, it will make the airplane go faster. So we know that this is go with the airplane. The wind go with the airplane. And of course, opposite direction will be go against, right? So when it's go with the airplane, the wind and the airplane rate will be the combination. So I call the airplane is A for the rate, and then the wind is W. And when we have opposite, so we have A minus W. Now we use the formula. A minus W, rate times the times, which is 5, equal 500. We set up the first equation. The second equation is A plus W times 4 equal 500. We will open the parentheses, so 5A minus 5W equal 500, and 4A plus 4W equal 500. We will eliminate either of them. So I look at the W, so I want to multiply by 4 and 5 so that I can eliminate the W, because 4 and 5, they both go to 20. So I will have 20A minus 20W and multiply both sides by 4 on the top and 5 in the bottom. So we got 2,000 20A plus 20W equal 2,500. Now we add them up, the W will be gone for us, so we have 48 equal 4,500. we will divide both sides by 40 to solve for A. So A will equal 112.5. And to solve for W, we can either plug into the first equation or the second equation. So I choose the first one. So this is the first one. So we have 8 is 112.5 minus W times 5 equal 500. So we will distribute the 5. So we will multiply 112.5 times 5. We will get 562.5 minus 5W equal 500. So we minus 562.5 both sides. So subtract. So we got 62 negative 0.5, yeah? Divide both sides by negative 5. Then we will get the answer is 12.5. So the speed of the airplane is 112.5 miles per hour. The speed of the wind will be 12.5 miles per hour. So we go back to the problem, and the problem asks us to find both the speed, the airplane and the wind. So we answered this question already. So what we can do is we can go back and check. We're gonna plug in the A in 112.5 minus 12.5 and 112.5 plus 12.5. Okay, so 112.5 minus 12.5, so we will get 100, and 112.5 at 12.5, so we get 125. So 100 multiply 5, so we get 500, and 125 multiplies by 4, we get 500 for the distance. So we get correct answer.